Thank you for joining us today. Chris already introduced me. My name is Konstantinos Arabatsis. I am the technical support engineer at BERGHOF Automation and Control Solutions. And hello, now it's working. And today I'm going to hold a presentation. Let's see the camera. Is it working better? Yes. For this tech talk. So about the topics, I will have a brief company introduction and product introduction, just like an overview. I'm not going into detail. And then I interviewed two of our customers, and I'm going to present a small application report on an industrial induction heating system that is using BERGHOF controllers and CODESYS, as well as a medical waste shredding and sterilization machine, which is also realized with our hardware. So let's get started. Who are we? BERGHOF Automation is your system provider for demanding control tasks in plant engineering and worldwide equipment. BERGHOF specializes in customized solutions based on a highly flexible standard portfolio, combining maximum fulfillment of requirements with maximum qualitative product safety. The hardware and software components impress with their sophisticated functions, maximum reliability, even under extreme loads. So yes, good marketing talk, but how does this hardware look? We have three basic product families. First one is the B-Premise series, which is in this case display devices, which have 2x2 different sub devices. First, we have the DC Pro, which is a PLC with integrated display functionality, targeting for target visualization. That ranges from 4 to 15 inches and uses resistive touch technology. It uses an ARM-based CPU and is also available with a dual-core CPU. The ET Pro is the small cousin. It is for an Ethernet terminal for showing a remote visualization and can be configured either as VNC, as a VNC client to show the VNC server of another controller, or in web mode to display the CODESYS web visualization. Also available from sizes from 4 to 15 inches. When we go to the DC Prime, it's again a display controller, but with a capacitive touchscreen that allows the use of multi-touch applications like pinch to zoom and sliding and everything else. Otherwise, the internal hardware is pretty much the same. The interfaces are the same, and it is also available with a dual-core CPU. And the same goes for the ET Prime. We strip the display from the control capabilities, and it is equipped with a VNC client and web visualization. Let's go to the B40 series. These are compact devices where we have 4 sub-devices. We have the CC Lite, which is an ultra-compact low-cost PLC. You see the photo, it almost has no interfaces and is most commonly used for as an IoT gateway, to gather data, or also as an automation server gateway. CC Slim is a little beef up. It is a compact controller with basically all necessary different interfaces that are commonly used in the industrial sector, and is also optionally available with a dual-core CPU. The CC Prime is another step up, which gets all the features of the CC Slim and adds or ups them with integrated digital inputs and outputs, and not only digital, but also analog input and output. Also available with a dual-core CPU, and the CCIO are just like EtherCAT IO modules that are in the same form factor, like to keep the aesthetics, or they're basically scaled up the same as the CC prime. Last but not least, we have the BENIMI series, which are our modular devices. And here, like, we have the newest product family, which is the MC Pi family. You can see 3 different devices, the Pro, Prime, Plus. These are all basically full blood PLCs using the Raspberry Pi CM4 as a hardware basis, but it runs with its own Linux systems, which makes it like a full-blooded CODESYS PLC. Additionally, with a different firmware that is using the standard Raspberry Pi OS, we have the BC Pi platform. The devices that you see on the photo just like are same basic hardware with different interfaces depending on the needs of the customer. And we continue with the MCIO, which is the modular-based I/O system that you can directly plug into the controllers. The bus here is used for is EtherCAT, and yes, like a lot of variety, digital, analog counter modules, temperature modules, and normally what normally is needed for different applications. And we have the safety PLC and safety PLC I/O in the same form factor, which are safety modules compatible with the CODESYS safety plugin, so that you can have all-in-one safety solution using our controllers with the safety PLC and a sub application that is running inside CODESYS. So you have one project where you have your application, where you have your visualization, and where you have your whole safety configuration inside here. Our platform and options, all of our PLC come with a custom-made real-time Linux made by BERGHOF. So it's from the kernel up, we developed the system by ourselves to match it as best as possible to the hardware and to get, like, for an embedded system, the best possible performance. All PLCs support and are programmed with the native CODESYS v3 IDE. We don't use any proprietary CODESYS IDE. We just like use the vanilla CODESYS that you can get from the CODESYS store, and you can get a target package from us, which will install all the necessary libraries and hardware descriptions, and basically you're ready to go. All PLCs can be customized with our software, with our option system. Basically, like if you order a PLC from us, you can select, okay, which software options do I need? According to this configuration, you will get it. Like communication protocols, which we support, are basically most of the protocols that CODESYS support: EtherCAT, Profinet, Ethernet IP, Modbus, CANopen, J1339, BACnet, KNX, OPC UA, SNMP, and other IoT parts. Of course, like we support most of the other CODESYS CODESYS features, web visualization, of course, like USB accessories, USB to CAN, USB to Ethernet, USB to serial, are like firmware features, FTP server, motion and soft motion, backup restore functionality on a system level, not only the one from CODESYS, application protection, like to protect your application from like intellectual property theft, IoT libraries, and we have also an integrated VPN functionality in our firmware, which we can use either with OpenVPN or with the Ixon platform. General fields for us are industrial machine building, like the classical German field, special machinery to control, like for a lot of different parts. Conveyor technology, basically it's a little bit specialized technology especially for rail guided systems that use a grinding can solution to be able to communicate with the devices that are on the field. And upcoming is building automation, where like we have like different parts like air control, climate control, heating systems, windows, and everything else. Actually, like just like an information here in our headquarters, we we did a big renovation of our main building, and the whole automation and the whole building automation is realized with our PLCs using KNX, BACnet, and the protocols that are provided inside CODESYS. Let's start with our first application, which is the induction heating systems. The company here is IDEA. IDEA GmbH manufactures modern and highly efficient energy sources for inductive heating systems. It was founded in 2009 in Pfalz-Grafenweiler. If you don't know German, that's a difficult one. IDEA released their first high-frequency generator with 200 kilowatt in 2010, and since then they have continued to innovate and expand their heating systems from cabinet-based generators to modular and mobile devices ranging from 1 kilowatt to 5,000 kilowatt power. Today, IDEA distributes the products worldwide and has excellent service for the customers at every task is analyzed before, thus providing an intelligent and customized solution for every challenge that the customer sets them. It is, in this case, not one machine that they're using our PLC for, but basically almost by now their whole product lineup. You can see the pictures, induction heating systems that are from 1 kilowatt to 5,000 kilowatt and from 2 kilohertz to 500 kilohertz with a tool change capability with a high matching range for endless opportunities for application. The systems rely on consistent modular design for its control cabinets. In this way, compact IP45 54, cabinet modules can be combined according to the requirements in order to enable maximum benefit with the smallest footprint. The modular concept has been implemented down to the smallest detail, not only to the smallest detail, but from the whole ranging, the whole product range that IDEA offers. They have like a modern generator technology in different variants at cabinet, which I can see here, mobile that I can see here, and tabletop generators that can be used. They have switchable frequencies and outputs, depending like on what material I want to heat, water-cooled systems with inlet temperature up to 37 degrees Celsius, air-cooled systems and cable, power and current regulation, custom-made coils and accessories, depending again on what you want to heat up, a wide range of heating processes that are used like basically for metal, like for hardening, tempering, straightening, and different other processes. And like as an additional service, they provide like a full simulation of the heat process. So it's not in part of the application, but part of the service. So when you go to them, like you do a full simulation for, and then you will get your custom-made calls. So you will get the best results in your heating systems. I have a small video that basically shows one, like we have here the coil and here the material that needs to be hardened. The coil is connected to the cabinet, which then gets a high frequency signal or like high frequency sent to and starts a heating process. Right. A small pause here. The heating process that you saw here was like actually recorded in slow motion. So the whole heating process and then the start of cooling actually takes around 200 milliseconds. So it's a very fast process, which is in this case, it was used for tempering. Oops, oh, sorry. The video was not done. What we see here actually is called deck straightening. So this is actually like quite often used at shipbuilding. When you mount your metal decks on these steel beams that you have here and you weld them, they bend. And by doing this heating process from the left and right, you can straighten out the metal plates again, and so that you can get a straight deck. So, like the quick demonstration that you have here, a generator, you can set different settings and heat up different materials. Let's continue. Why did they decide to use CODESYS and BERGHOF? They were actually already using CODESYS, but CODESYS V23, but as it was reaching basically like its limits and they wanted to update to a newer system, the update to CODESYS V3 was basically natural. Different V3 systems were tested with the conclusion that the native CODESYS is the best way to go forward, as branded versions came with a lot of unnecessary proprietary features, like updates were slow, or like there were no updates at all, and they tried to sell you a different license and different reasons. BERGHOF controllers, in this case, were chosen for the support of the native CODESYS, of course, support of almost all CODESYS features, which are used frequently, because we provide one target that supports basically one product generation. So like we have different product generation. If we take a look like at the CC primes or at the display devices that we have, we don't have like for one 15-inch or for a device without a display different targets, but it is one target device. Thus, it allows you here to scale your applications really up and down. So basically what they did here is they created one project, one application as a base for their whole product portfolio. The good performance and again, like excellent software maintenance with regular updates that are provided by us. Like we provide like normally 1 to 2 major updates per year, and are mostly up to date, or we can keep mostly up with the speed that CODESYS is bringing up updates. So basically like our SP19 update is not released yet, but it is planned for for the next weeks, hopefully. Which are the devices, field buses and periphery that were used for this application? You can see here basically not only they're using our PLCs in their whole portfolio, but they almost use all of our portfolio inside their devices. So it's quite different. Like for generators that don't have any display at all, they use the CC Slim, and these are like a small number, but most of the other generators need a display for options and settings, and here they use like the DC Pro and from 4 to 10 inches and the DC Prime. For all other variants, they use the remote panels, the ET Pros, for remote visualization. More on that a little bit later. And the IOs are done with our MC IO modules with different multifunctional IOs. The main field buses that are currently used are CANopen with a bus cycle time of 10 milliseconds and 6 slaves. Or up to 6 slave. In this case, they use up to 2 custom-made inverter controls for positioning, and up to 4 nanotech stepper controller for hydraulic operation of a high current switch. And of course, we use the EtherCAT with a bus cycle time of 4 milliseconds and up to 14 slaves, which is like one is a group of up to 5 MCIO modules, depending on the scaling on the machine and how many IOs are used. Then up to 8 custom-made high current switches for the generators. And depending on customer requirements, 1 field bus gateway. They like to use any bus here, like to integrate different buses, MFI, Profibus, Profinet. EtherCAT slave in this case, which unfortunately is not supported, encodes directly Ethernet IP and Modbus. For the future, it is planned to make a full switch to EtherCAT and reduce the bus cycle time to 2 milliseconds. As I mentioned in the demonstration, like the heating process can be very fast, 200 milliseconds for a heating process, and if they want to improve the heating processes even faster and get even more accurate, so they want to down the cycle time by throwing out the whole CAN bus and just concentrating on one field bus. What were the main challenges when they did the switch? Of course, it was like the switching from CODESYS v2.3 to v3. Everyone that has done it or has trained someone that claimed to be a very good CODESYS v3 user, v2.3 user, and then went over to v3. Yes, that's actually quite a difference. So the switch to there was okay, not so much CODESYS related, but also getting to know the BERGHOF system, because like it was quite different from the system they were using at the time. The next one was creating a one application fits all solutions, which like needed a lot of programming and optionality. And last but not least, master and client independent VISO switching and VISO handling. So that they have independent remote visualization and target visualizations. Key features in this case was for them the visualization and the modularity of the visualization. It had to be snappy, and they needed it locally and remote. But the biggest challenge in this case came from different requirements from different customers. Some customers like wanted a locally shown visualization and the remote visualization that are synchronized, and they basically show always the same, which actually is quite easy in CODESYS to realize by activating the current VISO variable in the VISO manager. Everyone that knows CODESYS most likely has encountered it. But by activating this variable, like it's a little bit of double-edged sword, the independent handling of the VISO clients is deactivated. But they also had customers that required the exact opposites. So they wanted a remote visualization that was shown independently, that I could check independently, that I could log in independently, without the main user, or like say like the technician that is working on field and sees the display or the local display, the target visualization, to see what is going to be done. It also goes farther, that they had one special customer that needed a combination of both. So when they were using the local target visualization or the local remote visualization over our ETs and web visualization, these two should be synchronized. But if they log in via VPN or with a remote access or just with a PC to some kind of maintenance or overview pages, this should be independent. So yeah, the requirements were actually like quite high. The solution is there in CODESYS. If you check out the CODESYS store, there is in the CODESYS store, or by now the CODESYS Forge, there is an example that is called client independent VISO switching that basically shows the basics. And based on this example and from like some support that they received from me, and I received from the CODESYS support, they made it realize. Like the most difficult part here is that these FBs, especially the VISO client FB, and the structures that are underlying there, they are not documented like for the open use. And in order to get to it and to work with it, there is a lot of trial and error, and like a lot of effort was poured into it until they could get this flexible solution that they're very happy with and that they know by now very well. Another key feature, of course, was the CODESYS converter. So they were able to convert the CODESYS v2 project to v3 with all the existing code. So when they did the switch, actually like the most effort did not went into the heating processes or the processes that they already had. Of course, they were expanded and optimized, but the general logic of the PLC was already there. So this was very helpful. And then like they focused on the features or the new features the CODESYS v3 allowed. The field buses that we have here, depending on the variant and the customer requirements, different field buses are used. The main field buses here are CANopen and EtherCAT. The CANopen implementation for nodes is perfect. Optional nodes work without any issues and easily allows to scale machines up or down. The same goes for the EtherCAT implementations. Here, where it can get a little bit more tricky, as you need like to flash some devices with hardware addresses and stuff like that. But it's basically a minor problem because again, you can work with optional devices in CODESYS v3, and it allows you to scale your machine and use either like one project for all, or create like a basic project, a basic applications that has the basic functionalities for all your variants of your machine, but then expanding this project for the custom devices. Again, what I also mentioned earlier is the control configuration and the flexible BERGHOF target, as it is like one device description fits all devices as long as you're inside the same generation, the same family. So IMX-based devices or are compatible with each other, and the same goes like for now, like for new devices. If I get an MC Pi controller, the Pi base, it does not matter if I use the Pro, Prime, or Plus device. It's just different interfaces, but the target and the application will run as is on other CODESYS devices as well. Other CODESYS features that are important is CODESYS SVN, the CODESYS recipe management to save and store data, the CODESYS alarm management, including the alarm history, which is like an easy to set up and use for showing and saving alarms, trace for diagnosing and monitoring of settings and machine behavior, and they're also using the CODESYS automation server for support and service. I'm just not sure if they're using a PC outside there. Otherwise, our PLCs also can be configured to be the edge gateway themselves. So we run the CODESYS edge gateway onto our devices. It's part of our runtime, and we can set them in configuration mode so that you can use the PLC itself as an edge gateway, as long as the PLC has an internet access. Some BERGHOF features that go inside here is like the ease of use of USB media for backing up data. We include first, like when you plug in a USB, we have an auto mounting, so that's pretty easy to use. But we have also a library that allows you to check plug status, to check how many devices are plugged in. Are they mounted? Are they not mounted? I can mount them manually or unmount them manually, so that I have full control of plugged-in USB media and to work with it. And again, additionally, we have like the BERGHOF USB update for every initial setup, which basically allows you like to create a pre-configured USB script, which you can configure your PLC, like basically every configuration. You can update the firmware, you can install licenses, and again, if you create a backup of the application that is already stored of the PLC using our feature, like our system feature, not the feature that is inside CODESYS, you can get an image basically of the application folders that are inside the PLC, and by that you can do a one USB update for all the needs. Like you plug it in, you reboot the device, the IP is set, the other settings are set, firmware, the matching firmware is installed to get also the matching runtime and your application. And in this case, they're also using different fonts because like they're using multi-language are already also installed. So far to this project, let's go to the second one. Customer information. ERMAFA stands for Erste Maschinenfabrik, which basically means translated first machine factory. Might as well be true. For more than 180 years, ERMAFA has been inspiring the world of mechanical engineering far beyond national borders. During this time, they have not only witnessed innovations and revolutions, they have been significantly involved in industrial turning points. To this day, ERMAFA is distinguished by its highly qualified development work and international references for rubber and plastic machinery, customized special machinery, as well as engineering service for automation project. It has always been their ambition to continuously improve their industry and its processes. For the purpose, they do research together with strong partners in order to develop innovations and to establish them worldwide. So far to the company. And now to the machine. What we have here is the MAX, the machine autoclave cutting sterilization. MAX offer a safe and economic high-end solution for the decontamination of medical, infectious, and other hazardous waste. The MAX technology is certified by German Robert Koch Institute. MAX surpasses the standard of WHO, which requires a sterility assurance level of 10 to the power of -6. And according to tests made by Bud Elser, MAX can reach an SAL from 10 to the power of -48. Some of the feature that you get here is like volume reduction of the medical waste. In this screen, you can see it quite well. Like you have different sizes of the machine, and you can get here medical waste, syringes, plastic, blood-soaked, or like other other bodily fluids-soaked tissues, and they're cut down, sterilized, and washed, so you can get safe to use and easy to transport waste, which then can be sent to different recycling stations. So what are like some of the main features of the MAX is reduction of waste volume up to 80%, liquid volume reduction up to 79%, on-site solutions for disposal of hazardous waste directly in the respective facility. So like basically if you have hospital clinics and you get this waste, you go down to the basement, you throw it inside there, and you will get easy to dispose waste out of that without expensive transportation route. Easy and safe use. MAX autoclaves are standalone solutions. It's an easy plug and play installation. They have automatic processes and highest security standards. All applications are equipped with emergency programs. They only need 3 connections for energy, water, and wastewater to be able to run. And the integrated software gets regular software updates and process optimizations, as well as regular backups and data storage, as well as remote access. Also for here, I have a demonstration video that was provided to me. I will just show it. Okay, I guess like with this video, now everybody should understand what this machine is actually doing. So let's jump into the technical part. First of all, again, why did they decide to use CODESYS in BERGHOF? Due to the global part shortage and like supply chain issues, ERMAFA started looking for second sources that use an open software concept, which allows them hardware independence and has low licensing cost, which like makes CODESYS basically the self-runner. It's the best choice. And as for the PLCs, like well, the feedback that I got is like we had a very good price to performance ratio. We had like the compact and modular design, and we supported the CODESYS, the native CODESYS, which like are traits of our PLCs, and they decided to use the MC Pi Pro for like the first instance. Which devices are actually used here? the MCPI Pro is used as the main controller of the machine. MCIO modules are with digital I/O and a CAN interface, a CAN gateway that is used also here. Why this combination is, when this project started, we did not have finished our MCPI Plus yet. The MCPI Plus is like the newest addition to the MCPI family, which adds serial connections and a CAN on board. And also I got the feedback that ERMAFA will change to this controller in the future to get the native CAN. So what are the field buses that on the periphery that is basically used right now? It's CAN open with a bus cycle time of 8 milliseconds and up to 8 slaves running at 500 kilobit per second. They use up to 5 Fuji frequency inverters, up to 2 linear access controls, and they have also 1 valve terminal for different valves inside, valve control inside the machine. EtherCut is used, like, of course, for the MCIO with a cycle time of 2 milliseconds and up to 3 slaves. And what is also used externally is like an external safety controller with an I/O interface to the PLC. So basically, if we go like into emergency stop or different, like I get an I/O signal to the PLC in order to have like a simple communication, as well as a thermal printer that is interfaced to the PLC using the FTP server. The thermal printer in this case is connected to an IPC, and the IPC is connected to the PLC via an FTP server to exchange data. Main challenges was that, like, natively they did not run a CODESYS system, so getting started. The further feedback that I received is that they already had ported like the application to CODESYS, but the programmer that is using it now did not like really the structure, the software structure, how it was structured. So the basic functionality was there, but he created more like modular structure, FB based, and different stuff. Getting the CAN bus to work with this MCIO module can be quite a little bit challenging if you don't know what you're doing. We're going to take a look inside here, and again, like creating an interface for the thermal printer is also like still a challenge, and how they basically solved it for now. When the project started, it was not possible to connect this thermal printer directly to the PLC. So like they had to use or look for like a workaround and how to do it. And in this case, the CODESYS file functionalities and the CODESYS file functions and libraries came in very handy, very handy, as it allowed them to create their own CSV files containing all the data that is needed. The PLC from us has an integrated FTP server, so you can just activate it over the settings. And if you you have a dedicated FTP folder, and if you just like copy the file into the FTP folder, the connected IPC that is there checks regularly if there are new files, and if there are new files, it will copy this CSV file and start printing it. Yes, and start printing it. Sorry, a little bit stalking here. And start printing it. So like the ability to create your own CSV files in the format that you need and to display all the data that you need by yourself is quite well here. They are also not using the CSV library from CODESYS, but they created or they implemented their CSV bright solutions by themselves. Additionally, like they're using the file libraries also a lot. They're using the alarm manager to display the alarms, but the logging is again done by themselves. They have their own solutions, and they also save all other kind of relevant data. So the ability from CODESYS to create files, text files, binary files, and save them onto the PLC is like very important for the solution they have right now. Let's go to the field buses in the task config. As I have mentioned, they are currently using CAN and EtherCut. EtherCut is used for our I/O, and the MCIO module, the CAN module that we have, when you install the package and you install the device descriptions, you also install, as we can say, a CAN mini driver, which basically translates EtherCAT to CAN and allows you to show the CAN port inside your hardware configuration as an actual CAN port. And it is not like some weird interface that I have to translate myself over the over the I/O mappings, but you get actual CAN port, and the library that is integrated is doing the whole translation for you. So otherwise, like this CAN port is then used as a native CAN port. You can add your CANopen manager, and you can add other CANopen slaves here. Like the screenshot is just like for showcasing how it looks. It is not like part of the application of the customer here. It will work out of the box. So if you just like enter everything and just leave the default settings for tasking and bus cycle times, it will work. But depending a little bit of the number of CAN slaves and the bus load and the speed that they're using the CAM, you might get connection timeout because like it is not very well synchronized. To properly run this combination, like in the case of this customer, but also with higher demanding tasks like also soft motion, which this module also has been used for, you need a little bit to know what this is done. Also, together with a programmer, like we did a small online webinar, a small online training where we did the correct configuration, which is basically what we did here. We created our own CAN bus task and the EtherCAT task, and the EtherCAT must be on a higher priority than the CAN. First and foremost, and the second one is that the EtherCAT bus cycle must be set also inside the CAN port. Why? Because the CAN port is actualized and is updated by the EtherCAT and not actually by the CAN bus. And the second CAN the CAN task that is used is set as the bus cycle task for the CANopen manager. And the last trick that I need to know is that the CAN bus cycle task has to be at least 4 times a factor 4 from the EtherCAT cycle. If it can be also faster, you can use it faster, and thus you have here the resulting to an 8ms. And after setting it up like that, and like also like configuring everything correct, the connection timeouts were gone and the CAN is working rock solid. Again, with the new device that is going to come with the MC-Pi Plus, this issue is solved by itself, as you don't have to use these interface and gateway modules anymore. The CODESYS visualization in this case is also used quite well. Like the display is done with the web visualization. They're using quite a lot of the CODESYS feature. One thing that they liked is like, of course, application and visualization is in one project, and you get direct access to all the variables that you have here, and the use of frame and like FB-like features that are possible inside CODESYS, like to create like one template and to make instances and using the same template at different places and doing it like that. The alarm configuration was easy to set up, and the automatically and dynamically display of active alarms is very well. They liked it a lot. And the web visu was also praised, like as it is basically just integrate web visualization, create your visus inside CODESYS editor by drag and dropping and configuring some of the elements, and just like by adding one feature, basically clicking one checkbox, you get a simple presentation on a browser, which then is showcased on an IPC in their machine. Other CODESYS features that they liked is generally CODESYS itself. Was praised. The IDE is easy to learn and easy to understand. The menus and configurations are often self-explanatory and intuitive. Also, like the online view and the debugging capabilities were very well with what they expected, and they like working with it. Some of the future challenges. This project is quite new. is to test the PLC as a Profinet controller, where they're going to use the Profinet controller feature that is inside CODESYS and is also supported by us. Then the thermal printer right now is connected to the IPC with a USB port. Unfortunately, our PLCs do not support printers over USB because like there are some driver issues, but the new version of the PLC has a serial interface and the printer also has a serial interface. So this is like one of the to-do to trying to skip the inner part of the IPC and connect the thermal printer directly to the PLC. They might check the optionality of field buses so that they can summarize different projects into one, like going again for the one project, all applications, all different variants. And last but not least, right now they're using an external safety solution. They are interested in checking out the CODESYS safety solution with our PLCs so that they can integrate everything into one project. And that's it for now. Thank you for your attention.